Hello everyone. So, we will discuss the fiber matrix interface bonding strength measurement. So, fiber matrix interface is the key factor which we need to know to assess the properties or quality of any composite material. So, fiber matrix interfacial bonding is one of the major parameters which determines the mechanical performance of composite. There are mainly 4 types of bonding mechanisms which actually determine the fiber matrix interfacial bonding strength. These are absorption and wetting. So, this mechanism is that the fiber has to actually absorb, the fibrous material should absorb the matrix and it should get wet with the matrix material and it forms bonding. Mainly this type of mechanism takes place in case of thermoset type of matrix, where the reinforcing material, that is fibrous material, get wet by the matrix material. Next is that mechanical keying. So, the unevenness, the roughness present in the fiber surface forms mechanical keying effect, which increases the bonding strength. And third one is the chemical reaction between the fiber and interface material and interface and the matrix material. And fourth one is electrostatic attraction. So, if we can create the electrostatic attraction between the reinforcing material and the matrix material, we can create the bonding strength. The measurement of bond strength is done using 4 different techniques, particularly for fiber reinforced polymers. So, these are single fiber pull out test, single fiber push out test, fiber push down test and full fragmentation test. So, the assumptions are, during the interface bond strength measurement is that no shear strain in the fiber during pull out. So, once we try to pull out the fiber, so there will not be any shear strain in the fiber and no transfer of normal stress across the fiber end. So, with these assumptions we can test the bond strength. The single fiber pull out test, it involves pulling a particularly fiber end which is partially embedded single reinforcing particle out of the block of matrix material. So, this is a matrix material block is created and the single fiber which is partially coming out from the matrix. This is only single fiber, and if we test, if we pull the fiber and once the fiber is coming out of this matrix from the composite material and this force is measured. That means, if the fiber breaks before it comes out, then the test method will not complete. So, partially embedded single reinforcing particles, like here particle is fiber out of the block of matrix material, this portion. Okay. Pull out leads to debonding. First it is debonding is taking place, then the propagation of debonding front, propagation will be there, then once the debonding and propagation is completed, then frictional sliding will be there. This test is actually applicable when the strength of the reinforcing material is very high, higher than the bonding strength. So, the drawbacks are the interfaces in the specimen may differ from those in real material, because here in the specimen which is created using a single fiber, the interfaces which is created here, it may be entirely different from actual composite material, because this is due to the absence of neighboring fibers. Here there is no neighboring fibers, but in composite material we have other fibers which interfere with the pulling out force and difficult to carry out, especially for the thin and brittle fiber. So, for very thin fiber the strength will be less. So, for those fibers it is very difficult to carry out, and also for brittle fiber the fiber may break before we start the test. Next method is single fiber push out test. What is that? Here the method is, here this is a composite and we use a single fiber here, and the fiber should be thick enough. After this the composite slice is made. There is a, this is a composite slice, very thin slice of composite is there, and here we have a single fiber. This is single fiber, and in this case the fiber, single fiber is pushed out by applying some force, the fiber will be pushed out, and this force is being measured. That is, in push out test the specimen in the form of thin slice with fiber axis normal to the plane of the slice. So, this is the plane here, and here the force, this is a single fiber, okay, single fiber, and this is the slice thickness, and fiber is being pushed out of this place. The fiber becomes displaced, so that it protrude from the bottom of the specimen, from other side it will come out. This test is easy with large diameter fiber, but for fine fibers it is difficult. So, the thickness of the fiber should be sufficient, otherwise it is very difficult to push out. So, this shows again debonding, propagation and frictional slide. Third method is fiber push down test. Here it is not the single fiber, here a bulk fiber. So, in the push down test, the specimen is in bulk form and debonding is followed by the fiber frictionally sliding down by over the certain distance. So, certain distance it will slide down and we can calculate the debonding force. This leaves a permanent displacement between the top of the fiber and the top of the matrix when the applied load is removed. So, there will be permanent deformation. Next technique is that it is a full fragmentation technique. This method is used for metal matrix composite and some polymer matrix composite also. This method involves embedding a single fiber in matrix and straining the matrix in tension parallel to the fiber. Now, this is matrix and here we have fiber material. Now, this matrix is being strained and in case the extensibility of matrix is higher than the reinforcing material, this is reinforcing material, there will be fragmentation of the reinforcing material. Now, this matrix is being strained to this dimension and the reinforcing material has got fragmented, and by studying the fragmentation and the aspect ratio we can actually calculate the debonding force. So, by applying the tension parallel to the fiber fractures and fragmented into the pieces, at different pieces it will be fragmented and aspect ratio exhibited by fiber segments are measured. Okay. So, these are the methods for measurement of debonding force. Okay. Next important characteristics of any composite material is void content, because the amount of void content in the composite material affect its mechanical characteristics significantly. So, voids are entrapped air in the composite. Okay. It may be entrapped air or any volatile material. Presence of void can drastically reduce the mechanical properties of the composites materials. During composite manufacturing, voids are eliminated by a process of consolidation which involves application of heat and pressure. So, by application of heat and pressure we can eliminate the void from the composite material. So, void content of a composite sample can be calculated using the formula which is by theoretical density and experimental density. So, theoretical density is sigma T and sigma E is the experimental density. So, using this formula we can calculate the void content sigma T minus sigma E by sigma T. The experimental density we can calculate by taking the mass of composite in air and the same specimen in water. So, this method can be used only if the density of the composite is more than the water, that is more than 1, if it is there, then we can use this technique. It is expected, that is the experimental density is the it is W A by W W by W A, where W A is the weight of composite specimen in air and W W is the weight of composite specimen in water. So, here we measure the weight in water as well as in air, and theoretical density we can calculate by knowing the fiber volume fraction. So, V f is the fiber volume fraction and density is sigma m is the density, this is the density of fiber. So, using this formula we can calculate the theoretical density of the composite material, and fiber volume fraction in the composite can be measured by. So, we have to calculate also, we have to measure actual fiber volume fraction of fiber V f. It is done by using image processing technique or matrix burn off technique or liquid digestion technique. So, matrix can be removed by using the burn off method or liquid digestion method. So, we can get the actual volume of fiber, and the fiber volume fraction is W f by sigma f, that is the mass of fiber by density of fiber, that is the volume of fiber, and divided by the volume of composite material. So, total volume of fibrous material divided by total volume of composite material. So, after measuring the void content, next important characteristics is the dynamic mechanical analysis. This is important for composite because composite during its application subject to various dynamic mechanical load and at different temperature, different conditions are there. So, dynamic mechanical analysis is used to study the viscoelastic behavior, glass transition temperature of the polymer. So, most of the plastic polymer, that is fiber reinforced polymers, are viscoelastic in nature. So, this viscoelastic behavior is actually assessed using DMA method. There are several types of DMA which have been used with composites, including torsion pendulum analysis and other resonant techniques. Okay. During a dynamic mechanical analysis test, a sinusoidal stress is applied. Here this is the grip, okay, and in between the grip there will be a specimen. Here this is a specimen here, and sinusoidal stress is applied, okay, and the strain in the material is measured, allowing one to determine the modulus. So, we can determine the modulus, and the temperature of the specimen or the frequency of test is changed, leading to variation in modulus. So, we change the temperature and frequency of stress and we measure the change in modulus also. So, here the test is carried out for storage modulus and for loss modulus. So, DMA measures stiffness, which is actually in phase component, that is storage modulus. Stiffness is nothing but the elastic component of the, and the damping also, which is viscous component. So, by this method we can measure stiffness and damping. These are reported as modulus and tan delta. The sinusoidal stress is applied, modulus can be expressed in terms of in phase component, that is storage modulus E dash, and out of phase component, which is loss modulus E double dash. The storage modulus is a measure of elastic response of the material. It measures the storage energy, okay, and the loss modulus, it measures the dissipated heat during testing, which is viscous response of the material. Tan delta is the ratio of loss to storage, okay, and is called the damping. So, loss modulus and storage modulus, if we take the ratio, we can get the damping value. It is a measure of energy dissipated of a material. Tan delta can be used to characterize the modulus of the material, and it is expressed by E double dash by E dash. So, where E double dash is loss modulus and E dash is storage modulus, and delta should range between 0 to 90 degree. This tan delta, this angle should be between 0 to 90 degree. As delta approaches 0, that means in that case it is also approaches the pure elastic behavior. So, as it is 0, that means it will be pure elastic behavior, where E double dash tends to 0. So, E double dash tends to 0 means it will become 0, this part. So, tan delta becomes 0. So, that shows the it is a pure elastic behavior, and as the delta approaches 90 degree, it will actually approach towards the pure viscous behavior. So, from tan delta value we can actually get the idea about the material behavior, whether it is a pure elastic material or pure viscous material. So, for thermoplastic composite, if we increase the temperature, so it will gradually from the, it will transmit it from the elastic behavior to the viscous behavior. So, this diagram shows in x axis we increase the temperature and y axis is the storage modulus. So, increasing the reinforcement content in the composite material diminishes the value of tan delta by imposing the restriction against molecular motion of the polymer chain. That means, if we incorporate the reinforcing material, the composite will become elastic. So, it will reduce the tan delta value, but if we increase the temperature, in this picture it shows if we increase the temperature, at lower temperature the storage modulus was high, but once we increase the temperature, the storage modulus suddenly drop after certain time, the E dash onset. So, it starts dropping, that means it is becoming a viscous flow is there. On the other hand, if we increase the temperature, the damping behavior, the tan delta is increasing and it is reaching to the maximum value. So, by imposing the restriction, once we add the reinforcing material, increase the content of reinforcing material. So, by imposing the restriction against the molecular motion of the polymer chain, it will show more potential to store the load, rather it is dissipating. So, it will actually allow the composite material to store the load. Otherwise, in absence of reinforcing material, it will try to lose the all this load value. Okay. Now, after all these tests which we have discussed, those are destructive in nature. That means, we test the composite which will not be reused, but in most of the applications the composite materials are applied in structural material. If we want to use the test methods which is destructive in nature, we cannot use for any structural material, but during the applications of all this composite in different structure, if we want to use, we have to select some non-destructive test of composite materials. So, there are different non-destructive methods which will actually help us to understand the characteristics of composite materials. So, why do we need to test the composite in non-destructive mode? So, the use of composite materials are increasing gradually in different service sectors, mainly due to their advantageous features over the standard materials. Composite materials are susceptible to flaws and damages which adversely affect the material quality and deteriorates the performance of the composite structure. Non-destructive testing methods detect the flaws and assess the integrity of the composite material without destroying the structure, which is extremely important. So, we have to assess the integrity of the material or integrity of the structure without destroying the structure. So, we can intermittently test the performance of the structure by non-destructive methods, and it minimizes the risk factors during service life of a composite material. So, during its service, like of aircraft structure, aircraft body, if we want to test whether there is any crack or any failure is there, so we can use non-destructive test method of the total structure. Here we cannot use the destructive test method. So, the driving force is there, the safety norms. So, there are different safety norms are there. Suppose a particular structure, we have to understand whether there is any internal damage took place or not in the structure which is already built. So, there is a norms we have to test, we have to understand the characteristics of the material during test. So, due to the safety norms we have to test the material, but if it is destructive in nature we cannot test. So, non-destructive testing is required. The regulations are there, government regulations are there, it is growing awareness of the safety of the structure is there. So, we must test the material, test the structure intermittently. Growing application need, technical progress is there. So, we can test the material without destroying the structure. So, due to the technical progress. So, these are the market dynamics, and different test technologies are there. The main technologies are radiography, thermography, shearography, ultrasonic inspection. So, ultrasonic inspection is there, where we use ultrasonic sound wave and assess the characteristics. So, I will discuss all these methods one by one. First is ultrasonic inspection. So, this method works based on the propagation of ultrasonic wave, which is ranging from 0.1 to 50 megahertz, that with that frequency through the material tested. So, the ultrasonic wave is propagated through the material. During testing, the sample is immersed in some liquid to separate the transducer and the test object. So, that transducer is there which will generate the ultrasound, and test specimen should be actually separated using some liquid. So, some liquid has to be applied on the surface of the test material. The transducer which generates the ultrasound is connected to a diagnostic machine and is passed over the object during test. So, the transducer is passed over the object. The ultrasound inspection works on two principles, one is reflection mode, another is attenuation mode. So, once it works on reflection mode, the ultrasound is actually it is falling on the material, and due to presence of some defects, it will get reflected, and that reflection is measured. And in attenuation, the ultrasound is passed through the material, and from other sound the recording is taking place. So, once it is working in reflection mode, the transducer performs both the sending and receiving of the ultrasound pulse wave. So, there are transducer, this is the transducer. Once it is in work in the reflection mode, this transducer actually perform both the its sending and receiving function. So, this sensor it is sending the ultrasound and it is receiving the ultrasound, and the time here it is measuring the peaks. Okay. This portion it is showing there is no defect. So, the ultrasound is passing through this composite, this portion composite material, and from other surface it is getting reflected, okay, and the peaks, even peaks are shown here. But once there are some defects or some cracks present inside the composite material, the ultrasound before it is reaching to the other surface, it is getting reflected from that portion, from the defect zone, and it is showing peaks in different form. So, by analyzing these graphs, one can locate, one can actually identify the defects present inside the structure. The diagnostic machine display the result in the form of signal, which is with the an amplitude representing the intensity of the reflection and the distance representing the arrival time of the reflection. So, from there we can actually identify the defects. Once the ultrasound system works on attenuation mode, a transmitter sends the ultrasound through one surface and the separator, actually that there will be a separate receiver which will detect the amount of sound, amount of the wave which will reach to the other surface. So, depending on the defect present in the structure, the amount of wave transmitting through the composite will change. The imperfections reduces the amount of ultrasound transmitted, thus revealing their presence. So, any defect present inside the structure can be identified. Finally, the diagnostic machine display the results in the form of signal. So, we can get the signal. So, it works on reflection mode and attenuation mode. And the advantages of ultrasound is, the ultrasonic inspection principle is that it is capable of detecting very small flaws from the deep of the sample. So, in case of there is a very small crack inside the composite material, it can detect greater accuracy than other non-destructive method, capable of estimating the size, orientation, shape and nature of the defect. So, for any sorts of defect, whether it is a void or crack or something else, it can detect. Non-hazardous, because it is a only ultrasound is created. So, it does not affect the human body to the operator or to nearby personnel, and has no effect on equipment and material in the vicinity. Capable of portable or highly automated operation. So, this can be actually transmitted, the total instrument can be taken to the structure and tested. Results are immediate, we can get the result immediately, hence on the spot decision can be taken. So, we can take decision on the spot because we get the result immediately. Main disadvantages of the ultrasonic inspections are, it is expensive and the extensive technical knowledge is required for the development of inspection process. So, for that it is becoming expensive. Thin, rough, irregular shaped sample are difficult to be inspected. What does it mean? So, rough sample, irregular sample, because here we need some liquid to be applied on the surface. If the surface is rough, then the application of the liquid is difficult. Surface must be prepared by cleaning and removing loose scales and paints. So, once we try to test or try to apply this technique in the existing big structure where it is painted or something is there in the surface, it is very difficult to use. Liquid medium are needed to provide effective transfer of ultrasonic wave energy between the transducer and parts being inspected. So, we need to apply liquid medium, and that is a disadvantage. It is very difficult to apply the liquid medium in some application where when it is vertically oriented or some curved orientation, in those applications it is difficult. Inspected items must not be affected by the liquid medium. So, the liquid medium which we use, it should not get affected by this liquid, it should not affect the item, the composite material. This liquid should not react with the matrix or the reinforcing material. So, next technique is that thermographic inspection technique. Here in this technique, the thermographic inspection of an object works through the imaging of thermal pattern at the object's surface. So, from other surface of the material we can actually get the thermal image. So, here it consists of IR camera which takes the image, control panel of the camera to. So, this is the control panel, we can control the camera, view screen and signal processor. These are the components. The defects encountered here, lack of adhesion of cohesion or bubbles. So, this type of defects, so bubble present or lack of adhesion we can measure using thermographic inspection, delamination we can measure, defects on surface coating, inclusion of foreign material in the composite material we can get by using thermographic inspection. A thermographic inspection instrument works on two principles. One is transmission technique, another is reflection technique. So, this is the technique for transmission mode, where this is applied, heat is applied, okay, and once the heat is applied, the heat will be transmitted evenly throughout the sample, and this sample in the left side it shows the sample without any defect. And once the heat is applied, this is the heat source, heat is applied with the sample with defect. Here, due to the presence of defect like crack or any other thing, the heat transmitted in other side will be non-uniform, and by using the thermal imaging camera we can image, we can take image the temperature distribution on the other side, and here this is showing the image on the other side, and this shows the defect present in the composite. Once this method works in the reflection mode, here the heat source and the camera is in the same direction. In left side it is showing the specimen without any defect, that means the reflection of heat is uniform. But on the other hand, with defect, as there is a defect present here, the heat reflected will be totally different in the defective zone than in normal zone. So, in case of transmission mode, the heat transmitted in the defective zone will be less than in the normal zone. But on the other hand, in case of reflection mode, the heat transmitted, heat reflected in the defective zone is more than the normal zone. This is shown by these graphs. Here it is a time and it is a temperature. In case of reflection mode, the temperature at the defective zone is higher than the normal portion, whereas in case of transmission mode this is lower, heat in the temperature in the defective zone is lower. So, by analyzing these graphs and the pictures, we can get idea about the defects present inside the composite structure. So, the advantages of the method is that it is a global examination of parts, only one side access is required for the examination, that is the heat is applied from one side, and if it is the reflection mode is used, only one side access is enough. Real time inspection apply for all composite structure and material. So, we do not need to apply any liquid medium here, well suited for large surface. For large surface we can use, but main disadvantages of this technique is it is sensitive to heating mode. So, if we change the mode of heating, that is type of heating, duration of heating or position of heating, the result will change. Suppose we change the distance of heat source from the composite material, the heat transmitted on the other side or heat reflected will be entirely different. The response time must be studied, okay, and exact composition of the piece and the thickness must be known, because if it is the thermoplastic composite and the melting point is low, that will affect the composite. Inhomogeneous heating on complex part, that is the main drawback of this technique, because in case of complex part the heating will not be uniform. Let us see, suppose this is a composite which is straight uniform. So, once it is heated, the heating will be uniform throughout the surface and the heat transmission will be uniform. Suppose there is no defect, perfect composite. Another composite of say complex structure, this is the composite material without any defect, this is a composite material. Now, if we apply heat here, so heat transmission will not be uniform, which is very difficult to assess whether this difference in temperature on the other side is due to the structure or presence of any defect inside the structure. So, that is why it is very difficult to assess the composite defect for inhomogeneous complex material. So, there will be inhomogeneous heating on the complex part of the composite, and next technique is the radiographic inspection technique. So, this technique we will discuss in the next class. So, till then thank you for patient hearing.